Hello everyone, in this video I'm going to show you another example on calculating derivatives, but this time we're going to do it in a slightly different context. This time I'm going to apply derivative rules in some physics equations. So the first equation says P of t equals 5t plus 9, and P of t is a way of representing the position of an object. So in this example, if we plugged in, for example, 0 for t, which stands for time, we get 9, which means at a time of 0, the position of this object will be 9. And the units for time and the actual distance could vary, but since P of t equals 9 at t equals 0, we're basically being told that at the start, this object is already at a position of 9. Now we also need to find an equation for v of t, or the velocity of this object, based on its position for time. Now velocity is the derivative of position, and this is because velocity is defined as the change in position, or displacement, divided by change in time. So to find v of t, we need to take the derivative of p of t, and that derivative is 5. Because the slope of that graph would be 5, the constant term 9 does not affect slope, and the number we're multiplying our variable by is 5. Now similarly, if we had to find a graph for a of t, or an equation for a of t, that's the acceleration of this object as a function of time, we would take the derivative of velocity, and that's because acceleration is defined as the change in velocity over time, over change in time. Now you'll notice that v of t is a constant 5, which means that for any time t, regardless of what time that is, the velocity of this object will always be 5. And since there's no change in velocity at all, that means our acceleration will be 0. And by taking the derivative of v of t equals 5, we would also get 0, because 5 is just a constant number. So this was just a quick summary on how we can create an equation for velocity and acceleration given a position function, and we did this using the same basic derivative rules that we would normally use.